Okay, so we're just looking at the first of 3 videos on what we're calling simple parabolas. So let's define what a parabola is. So when we have a function where the highest, okay, my pen right. So when the highest power of the variable, and the variable is usually x, but it can be another letter. So when the highest power is equal to 2, okay, we have a function, and we call this a quadratic function, okay, and the shape of the function is called a parabola. So a quadratic function has a shape of a parabola, and what we're looking for is that the variable, which is usually x, the highest power equals 2. That's what you're looking for. Okay, so copy that and come across when you're ready. So here's some examples of parabolas. Okay, the variable, the function is reading y values off x values. The highest power is 2, so that's a parabola. The variable is x, the highest power is 2, so that's a parabola. The variable is x, the highest power is 2, so that's a parabola. Now these last two, if I multiply x by x, I'm going to get an x squared term, so that's a parabola. If I expand this bracket out, I'm going to get an x squared, so that's a parabola. So you're just looking for, can you get an x squared? And if you do, then that's a parabola. They're all quadratic functions. Okay, so copy them down there. So they're all quadratic functions. Okay, they're all therefore the shape is called a parabola. Okay, so copy that and come across. Okay, so let's have a look at what the shape of a parabola is. Excuse me. It looks like a sort of a cup shape. Okay, so again, like we're measuring y versus x. Okay, so just in case, we call this the independent variable, if you want to be independent variable, like you can just have values for that, and y, we call that the dependent variable. That's stuff that you should have known, but if you didn't, then that's okay. So this is independent because you can make up values, but the y value depends on the x value. Anyway, so going back to the shape, it's a cup shape, and there is a symmetry about it where if you put a mirror, okay, you could put a mirror there, like, and the shape is symmetrical on this side as on that side. So once you've got one side, you've automatically got the other side. And we call this line where the symmetry starts, we call this the line of symmetry, or the axial symmetry sometimes. Axial symmetry. Okay, so where a mirror could be put, where the shape is symmetrical, we call that the line of symmetry, or properly the axial symmetry. So copy that and come across. Okay, excuse me. So for instance, if I've got that, okay, the x squared means it's quadratic, which means it's a parabola, and if the x squared is positive, then we have these shapes that are concave up, and sometimes we say that they're smiley faces. Okay, that's not mathematically smiley face, but we call them concave up. And if you have a concave down parabola, it's because the x squared term has a negative in front of it. Okay, so if the x squared has a negative coefficient, then we call them concave down, and sometimes in classes they might call them sad face. Okay, sad face. Okay, so if the x squared is positive, it's concave up. If the x squared is negative, it's concave down. So copy that and come across when you're ready. Got one more slide to go. Okay, the last part of this first introduction is just on these terms that we use. Okay, so the bottom of the curve or the top of the curve has names. The bottom of the curve, we call that a minimum turning point. Now, why do we call it a turning point? Is because it turns and goes up, or it turns and goes down. So this first one is called a minimum turning point, and this one is obviously called a maximum turning point, but it's where the curve goes in the opposite direction. Okay, and obviously the turning point has a lot to do with that axial symmetry. Okay, so from the previous page, axial symmetry. So the axial symmetry is where the turning point is going to be found. Okay, and that's the end of the first video. Thanks, bye.